Hello again. We are still in chapter 2 dealing with loops or repetitions, but in this worked example, instead of using while keyword or while construct, we are going to analyze a program that implements loops by using the for construct or the for keyword. Now, this is more or less the same program that we have just finished analyzing, but the last one was using while construct, while the one that we are going to look at now is going to use the for keyword to implement the repetition. As you can see, here the variable I is initialized, it is tested, and it is incremented in one single line. And now the repetition is only done with respect to n because the incrementation of I is done in the loop itself. So this is the end of the program, and if we look at the program from the word point of view, we can see this is our text where variable I is being declared here. After being declared, no value is entered, value n is declared of type int, then 1 is entered into it, and here the loop is set. But at setting the loop, I as a variable is assigned 1, and then the computer will have to check if the value in I is less than 5, then I will be incremented, but along with that, then n will be added with the content of I, and the condition will be checked from here. If it satisfies, repetition will go on until when the condition does not satisfy. Let us now go and see how this program will execute in the compiler environment. This is the same code. Libraries, int main, starting and ending here, and here are variables being declared. Variables of type integer, int I, and n is assigned 1. Then the loop is set here. For I equal to 1, I less than 5, plus I, n equal to n plus I. If we compile this program and if we run it, we are getting result that the value in n is 11 and the value in I is 5, just as we were getting when we are using the while construct. Now we can come here and add the upper limit. Let's say while I less than 55. What will happen? This particular action will repeat until I is equal to 55 or greater than 55. That is when the condition will break. Now if we compile here, there is no error. If we run, we are finding that the value in n is 1486, while the value in I is 55, which enabled this particular loop to break and the program to come to its end. So, in the way we have been approaching this discussion, we were able to visualize the code in text and analyze it using normal language. We were able to visualize the code in the compiling environment and try to understand it. The next video will be about visualizing this code by using what we call physical RAM diagrams. And then we shall use what we call RAM diagrams, which are the drawn, the picture, which is going to reflect the computer memory. For now, I am thanking you, and I would say bye